Welcome back everyone in the series of C programming tutorial. In the last class, we have discussed about some application related to the array, right? Where we have seen the linear search of searching an item in a given array, how we can do the random access with the index in an array of item, and is one of the example also under algorithm implementation, that why someone should prefer array over other data type, right? Okay, so in continuation to this, now we're going to see another algorithm that can normally always implemented with 1D array, okay, that is sorting. Okay, so we'll see now how to sort an array using a technique called bubble sort. Okay, why this technique is called bubble sort? There are many other techniques, but I'll not going to include other sorting algorithm in this playlist because this will be part of a separate topic, data structure sorting techniques, right? So just to make you understand the iterative process and the application in algorithm domain of one-dimensional array, I have just picked this topic, and it is also required to discuss sorting technique. I've used the simplest one, bubble sort, which will execute up to n square amount of time, right? And we'll use further this technique to design another searching algorithm, that is binary search, in after this lecture. Okay, binary search, SEARCH, right? Fine. So now let's focus on the bubble sort and let's see the algorithm, and then we'll write the code in C language in GDB compiler and we'll see how it is works, right? Okay, so initially the algorithm starts with that particular input. Okay, so you can take an input as an array. Okay, input as an array, and let us design the code up to this. We'll discuss the algorithm and write down the code at the same time. Okay, so let's design the code which will take the array as input and its size is n, means size is not predefined. So how to do that? Previously we have told that size of the array should be a fixed size integer constant, right? But if we want to implement based on the user input how many item that should be the part of the array, how we can do? So now I'm introducing one concept called hash define. Okay, it is a preprocessor directive, can be used to define the size of the array in larger size, and will ask the user to enter the size of the array which will be minimum than the size that I'm going to define here. Okay, so I've defined an array with larger size as 100, right? So let us define it. Integer, we have the numbers, and we'll use a size over here. Okay, now see, because we are working with the static memory allocation here, we cannot make the everything in totally dynamic, and neither we can just do this, never do this. I saw some of the students do this thing, take n and immediately take a scanf from the user, okay, as the size of the array, and instead of a fixed size they use this variable size. Now look at, array memory must be reserved at compile time, but due to this nature what is happening, your array memory is not reserved at compile time, it depends on runtime, because the value of n that you're going to give input, it is on runtime only once the exe is running. So this is not the way to do that. Sometimes you will not face issue, sometimes you will definitely face the issue, right? So what is the best approach? You can ask the number of items that user wants to enter into the array, right? There is no problem, but you should pre-allocate the size in larger way, okay, more size, which will be normally the size might be user must enter less than the given size. So in that case what we can do, we can use another constant that we can declare with a preprocessor directive hash define, and this preprocessor directive, this is the name and this will be the value. Preprocessor directive will always come in a pair of name and value. So whenever in your program compiler find this name size, it will be replaced by its value 100. Okay, so because when you start compiling, the very first stage is pre-processing before compilation start. Okay, even though before creation of the exa, right? So that can be taken care by the preprocessor as another system program which is part of the compiler, right? So now you can ask the user, suppose I am asking now, enter the QUI ready required size of the array. Okay, you can give a message that should be a positive size of the array. Okay, and then it will take the input. And now that the array that I have taken here, let me just shift it here. Okay, so it will, my array is done, and I'll take number of items that user wants to enter. So now you can control your array, okay, up to the given size by the user. Okay, so now you need to build the logic here. If n is greater than equal to 0, it should be positive as well, and n must be less than size. Okay, I hope you understand now. Size. Okay, fine. Okay, inside this we're going to build the complete logic. Else we can just add one statement here. Size the and given size is not valid, right? The given size is not valid. Should be, you can use one \n, should be less than %d, and it will be replaced by its value. Okay, done. Let us just test it. So enter the size. Suppose I size give 400. The given size is not valid, should be less than 100, because this is compile time memory location. We have to restrict at some point of time. Fine. So now once the user enter, so next step is what we need to do. We need to take the input from the user. So let us take the input from the user for integer I equal to 0. Done. I less than till n only, and I plus plus. So I'll give a message here, printf, enter values at, we can print the name of the array as well as the location. Okay, so we need to print here I, fine, and we need to allocate the value in a given memory block. So we need to pass the address of nums of I. Done. So our input is ready. Now if input is ready, you can just print it to check is everything is okay or not. So it will take care of our input. So comment it, input. Now display, display numbers. Here let us just display. So we no need the scanf, and we're going to just print the number as %d, right? And we just passing here nums of I. Okay, once we've done the printing, we need to just move it to the next line. Okay, now let's go back to the algorithm. Here what we have done, we have taken the input of the array with the size n, we have determined from the user input. Now there will be two loops, you can see, one is the outer loop and another is the inner loop. Okay, so I preferred always for loop. Okay, so I always prefer the for loop for this purpose. So how it will work? See, if I just take an example here, let me just discuss the algorithm in here, and then we'll write the code. Okay, these are the locations. So let us take some number, 17, 5, 3, 10, now 9, then 2, and then suppose another number 7. Okay, so how it will works? See, We'll take two loop. One is the outer loop. So outer loop will be represented by I. So I will point one number, and through the inner loop we'll compare with rest of the numbers. Okay, we'll compare ith value with all the remaining items, right? So inner loop, so for each iteration of the outer loop, it will iterate up to j, will iterate up to from 0 to n minus I minus 2, 0 to n minus I minus 2. Okay, so that means our I will be controlled by the outer loop and j will be controlled by the inner loop. So every time our iteration will start from the 0th index. So j will always here, j will always here. So now if I do the comparison, look at now. Okay, look at how we do the comparison. We'll compare with the ARR of j. So for an example here, in our case it is nums, with the jth plus 1 item. So it will get compared with this j plus 1 item. This is j plus 1. So now if I compare, 17 is greater than, okay, that is 5, yes. So what I need to do, if it is greater than, look at here, swap the two elements, means this value will be coming here and this value will be gone over there, because 17 is greater than 5, and we are sorting normally we do in ascending order. That means smallest to largest. We can do the descending based on our criteria requirement, right? So now we'll continue, we'll increment the j. So if I increment the j, now j will be here in the next iteration of the inner loop, j plus plus. I will remain in this position only. Okay, I will remain in this position only. There is no change. Then 17 will be here. So next j plus 1 is here. Okay, so now we are comparing 17 and 5 is here. So 17 and 3, 17 greater than 3, yes. So swap. So if I further swap, what will happen? 3 will be here and 17 will be here. And now again j plus plus, j will be here. 17 greater than 10, yes, 17 greater than 10, right? So 10 will be here and 17 will be here. Further j plus 1, okay. So I need to swap it. So 9 will be here and 17 will be here. So this way it will continue. At some point of time our 7 will be here and 17 will be here. So after the first iteration of the loop, the number will be look like 5, 3, 10, 9, 2, 7 and 17. So see what happens. Until the largest unsorted element bubbles up to its correct position. So what is happening after the first iteration of the inner loop? The largest element at its place. So now what is I? What was I? I was 0, right? So how many comparisons we have done? N. N is how much? 1, 2, 3, 4, 5, 6, 7. Okay. 7 minus I is 0 and minus 2. Less than this, okay, because see here 7 minus 2 is actually how many? Less than 5. I'll continue for the j, and the item will be compared because I'm also referring one advanced index j plus 1. So if j is going up to 4, I will compare to the 5th item as well. So there is the index. So it should be less than equal to. So if it is go up to 5, it will go up to 6. So right. So j will here. So I'll compare j plus 1 as well. So I'll comparing all the numbers. So after the first iteration, the largest element at its place. So next time I no need to compare this number. I'll compare up to this much. Okay. So I hope you understand this process, right? So let's build the loop. Okay, so now the outer loop. It will go up to my n and sorry, I plus plus, right? And now my inner loop, I'll start from j. So j will iterate always from 0 number, 0th index. Okay, it will go up to n minus I minus 2, right? N minus I minus 2, got it? And j plus plus, j plus plus, done. J plus plus, done. Okay, so now let's do the comparison. So I'm comparing now the nums of j if it is greater than nums of j plus 1. So what we can do, we need to swap the elements. So let us swap the elements. So for swapping, we'll use another variable temp. So temp equal to nums of j, and nums of j will be updated by nums of j plus 1 item, got it? And nums of j plus 1 item will be updated by nums of j, which is holding by now temp. Okay, so this is my swapping information. Okay, and after every swapping or every iteration, so let us print the array, okay, and see how much array is already sorted. So I'm just going to print it here. Normally we design this kind of stuff with the function. So right now we did not discuss the function, so we'll write everything inside the main only. Okay, so I hope you understand here. There is another part in the algorithm. See the step number 6. Break the outer loop early if no swap were made in the inner loop. Means if I take an example, okay, if I take an example, suppose if I take an example like this, 19, then suppose now if I take 3, 4, 6, okay, 8. Okay, now you can see the first number is only not sorted, other than all the numbers are sorted. So after first iteration, when it will be look like this, first inner iteration, once the inner iteration completed, okay, now after second iteration, it will be look like this. Next iteration, it will be look like this. And thereafter, for further iteration, inner iteration, it will be look like this. So once the 19 is here, means one outer iteration completed. And what you are seeing here, this is called swapping of items, right? So we done the swapping, we done the next swapping here. So all the swappings are taken care by inner loop. Now after the first outer loop, you can see the array is already sorted. So next time unnecessary comparison again we are doing. Is it 3 greater than 4? No. So again we are comparing 4 greater than 6? No. 6 greater than 8? No. Unnecessary comparison. Thereafter again we are comparing 4 greater than 6? No. 6 greater than 8? No. Further 6 greater than 8? No. Okay, unnecessary comparison we are doing. So we can introduce one variable, swap variable here, which will track is actually swapping is done or not. If there is no swapping done, so that means array is already sorted. Okay, so for the time being, I'll implement the bubble sort without using the swapping variable. We'll use the letter. Okay, so let's check it. So this is the outer for loop which will target the particular item. Okay, and it will just give me the iteration, number of iterations. Okay, we'll always start comparing from the 0th location. It will go up to this. Okay, so that unnecessary comparisons are not necessary, because after the iteration, every iteration largest element will be bubbled in its place, right? and if that particular condition, that is jth item is greater than the next item, definitely we will swap their values in the position. So here I have done the swapping using a third variable. So temp will be holding the jth item, and jth item will be updated by j plus 1 item, and j plus 1 item will be updated by the temp. After every completion of the inner loop, complete iteration of inner loop, we'll see the outcome of the array, that how much it is sorted. Okay, so now I think better to shift it on this side. Yes, fine. And let us execute the code and see. Okay, it is asking for the size of the array, right? So if I just enter a correct size, suppose I want 8. Okay, asking for the number. So 78, now 45, 7, 2, 1, okay, 9, 20, and 100. Okay, now see, I have given the largest number as the last number. So definitely after the first iteration, you can see here, this is the array that I have printed through this for loop. Okay, this is the input is over, and this is the first time I have given you the array. This is the input array. Okay, now next time what we are doing, we have started comparison. So we started comparison. Now look at how it is works. Please do this dry run, else you will not understand the code. Okay, now see what I am doing. I equal to 0. So where is my I? I is right now here. Where is my I? Right? Okay. Then I less than and true. J is also here. Okay. I, J both is here. So I comma J both holding the value 78. Okay. Right. Next, it will go. Now check this one. If nums of j greater than j plus 1. So what is j plus 1? J plus 1 is this. Okay. Is it greater than? Yes. So we are comparing 78 is greater than 45. Is it greater than? Yes, it is true. So if it is true, we'll do the swap. So if you do the swap, what will happen now? What will happen? I did not print after every swap. So let me just print after every swap. Okay, so that you can see the output after every swap. Yes. So here it is. Okay, and printf \n is necessary. You can print here one line after swap. Done. So now let's run this code again. Okay, some issue. Where is the line number 35? Semicolon is missing. Now run. Another issue, line number 43. Else. We have written if here, and this else is saying line number 43. Okay. Let me just close this. Yeah. Now run. What is the issue? 1 minute. Let me just remove them and come back to the actual code, that which is actually working. Now let's run. Yes, okay, we'll take care. We want that it should print, right? Okay, so let me just, yeah, that for loop I did not copy it properly last time. So my inner for loop, yes, now run. Yes, now it is fine. Okay, got it. So now let us just take 8 numbers. 17, okay, 5, 4, 1, 9, 8, 12, okay, and suppose now 3. Okay, so now let's see how it is works. This is the actual input. Now shifted, see, 17 is comparing with 5, 17 is greater than. 17 is further comparing with 4, 17 shifted. 17 is further comparing with 1, 17 shifted. 17 is further comparing with 9, 17 shifted. We're further comparing with 8 and 12, okay, and 3. So this is the iteration, complete iteration of the from here to here. You can see the inner loop complete iteration, okay, and then it prints the array. This is the final array. Now I am comparing 4 with 5, okay, 4 with 5 again. 5 is greater than, so 5 shifted, greater than shifted, not greater than, not shifted, okay, not shifted, not shifted, not shifted, okay, not greater than, not, so already it is comparing, right? Now further we found there is a 3, so now you can see 3 and see 3 is shifting over there. 9 greater than 8, no. 8 greater than 12, 9 greater than 8, yes, so 9 is shifted. 9 greater than 12, no. 12 greater than 3, yes, so 12 and 3 is shifted. So now see 12 at its place. This is the second iteration, got it? And now this is our final sorted array, right? So now here you just add one more line, not after the if, yeah, here printf after swapping, and run it again. Okay, so let us take 8 numbers. So let us take 4, sorry, 5, 8, 5, 12, 9, 20, 11, and you can see a complete number. After swapping, you can see that 5 has swapped its position, okay. After swapping, we get the outcome. Then again 8 has been swapped with the 5, then you can see 12 with the 12 is swapped after with the 9, like that. So sometimes we saw that, see here, after a few iterations, if you look at carefully, 8, 9, this particular, even see here, even this here, the array is already sorted. Unnecessary comparison we are doing. So please keep in mind this input 4, 5, 8, 5, 12, 9, 20, 11 in this fashion. Unnecessary comparison we have done. So now if we somehow track this, actually swapping is not done. So still we are doing the swapping. So I am going to introduce another variable now, like last example. So we are going to introduce another one now, hash include stdbull.h, sorry, stdbull.h, done. And here we are introducing another variable, bull swapped initially as false. All right, okay. So now if swapping is not done, so here it is coming with swapping or swapped, what is the name? Swapped, not swapping, sorry, swapped not done, so I make it false. And now here swapping done, so I will make it true, swapped equal to true. So if swapping done, I'm going to the outer loop now, okay. So this is my outer loop, so let me just remove all the display, this display, yeah, inner loop display, done. Same code we have pasted because we have not discussed the function yet, so you are not ready to understand this, okay. Remove this. So our for loop is done, both the for loop, yeah, done now. If is close, that is, yeah, now. And this one is also not necessary. Now we are printing, and outer for loop, this is, I think it is okay. Now just test the code. No, again issue, swapping equal to true, where I have written swapping equal to true, it says that undeclared variable. Oh, it is swapped, not swapping, swapped true. So now if swapping not done, it will be remain as false, right? Okay, so here you can do a stuff, breakout from the outer for loop. So if not swapped, immediately break, run. Okay, so now let us just take 8 numbers. We'll do 15. Okay, 3, 4, 5, 7, 8, 11, 10. Okay, now see how many iterations I have completed within the 3 iterations. Because see, these numbers are already sorted. 3, 4, 5, 7, 8. These numbers are already sorted. 3, 4, 5, 7, 8. So no need to unnecessary comparison. If I just remove this swap variable, you can see all the comparisons are done. Okay, this is the benefit you can get if you introduce the swap variable. Without swap variable also your code will work, as we have just seen, because unnecessary comparison is doing. So let's go back to the algorithm now. If I just see the algorithm, break the outer loop early if no swaps were made in the inner loop. So how I have tested, whenever my outer loop started the iteration, I set the flag variable, sorry, swap variable to false. Once swapping has been done, that means my program control is inside the if block. It means swapping done. So I make that as a true. So when it is true, then we are checking if not true. If not true means what? False. Means my program control never visited this particular if block. No swapping done. So if no swapping done means array is already sorted. If array is already sorted, just break it out. Okay, so you can try this with a already sorted array. So let me take 8 numbers, sorted array: 1, 2, 3, 4, 5, 6, 7, and 8. You can see no loop has been ever executed. Inner loop is never executed. It is always checked that array is already sorted. No need to compare. So here we are handling only 8 numbers. Think about millions of number in a database when you're going to sort it. The database engine going to sort it, right? So this is the one of the handy thing you can do. You can change the comparison. Instead of less than, you can do greater than. You can do the less than, and it will the array will be sorted in descending order. Let us try. Okay, 8. So if I now give 1, 2, 3, 4, 5, 6, 7, and 8. Now see, all the swapping has been done. So how many numbers? 8 numbers are there, right? So I've given an ascending order array. Now it prints me array in descending order. Okay, after the sorting, array will be in descending order. So you can easily just change this operator where you do the comparison. If you look for the bubble will be settle the largest element, you can change it to the greater than, and if you want it should be smallest number should be bubbled, you can do that less than. Okay, so both it will work, just depends how you're going to compare it. Okay, I hope you like this bubble sort. We are slowly moving to the advanced concept, so please rewind the video and check and take different types of array and understand number of times for loop executed the inner for loop and how many times the outer for loop get executed, so that you can understand other algorithm that you're going to discuss. I'm going to discuss in the next video binary searching, because for binary searching I will need this code, the sorting array normally we give as an input. Okay, so I hope you like this video. Please do comment and share with your friends, and do not forget to subscribe my channel. Okay, have a nice day. Thank you.